In this video, we will check out some questions from SAT Practice Test number 8. This is accessible through the College Board's website, and we'll be working out a section 3 within the problems that we check out here. These are non-calculator math questions. So if we just dive right in here, problem number 1 tells us in the equation above, we want to know the value of x. So this is kind of a crazy looking equation. You see I put some coefficients here in front of the x's. They basically gave us an equation with a bunch of terms that weren't yet combined. And so I've tried to highlight all of the like terms on the left that involved x in yellow. And if I have 3x, 1x, 1x, and 1x, that'll give me a 6x total on the left. So those on the left side that are highlighted in yellow turned into this. The minus 3 and then the minus 2 more, those are going to combine to the minus 5 that you see also on the left side of the equation. And then I used a similar strategy on the right. Now I didn't have anything to combine with the 7, so the 7 just copied in, but then the 1x and the 1x, those are obviously like terms. I can combine those, and those will of course combine to 2x. Now if I'm trying to solve this for x, I'm going to have to get all of my x's onto the same side of the equation. So I look at this and I think, well, I've got 6 x's here, I've got 2 x's there. If I can, I like to try to keep the coefficient of x positive, and so that, in my mind, made sense for me to subtract 2x from both sides, so that over here, these are going to cancel with each other, and then 6x minus 2x, those like terms combine to 4x, and then I'm also going to want to move the numbers onto the opposite side. So if I'm grouping the x's on the left, I want the numbers to accumulate on the right, and I'm going to get rid of that minus 5 by adding 5 so that these cancel with each other, and then 7 plus 5 is 12. I need to undo that multiplication, giving me an answer of 3 for x. Next question here presents us with this graph. If you look at the graph, it's distance plotted on the y-axis being measured in feet, and then time plotted on the x-axis measured in minutes. Now one thing that you'll notice they've done is they have changed the variables on the x and y-axis to d and m. The m in particular is something that we have to be cautious of because we use the letter m for something a lot in math, especially when there are lines involved, and that's exactly what you see graphed here. We can't confuse this right here, this m, with slope. It's not slope, it's the variable m for minutes, time measured in minutes. So the description here basically tells us what we already kind of could have inferred by just looking at the graph, but the question here is which of the following equations correctly relates d and m? So we basically want an equation for this line that's graphed right here. Now, I'm going to kick over to slope-intercept form for about 30 seconds. I'm comfortable building equations in slope-intercept form. Like I mentioned 30 seconds ago, don't confuse the m that is right here in this equation with the m that's one of the variables within this problem. We'll revert back to the variables in the problem once we're getting ready to sync up our answer with one of the options. So I know to build this slope-intercept equation, I need to know two things. I need to know what the slope is, and to find the slope, if I have the graph in front of me, it's oftentimes easiest just to count a rise over a run. So if I start at this point right here where grid lines are crossing and work up to this point right here where my line is crossing through grid lines again, my rise would be 2, my run would be 1, so my rise divided by my run is 2. My slope is 2. Now the y-intercept of this graph is 0, right? This graph starts at the origin. So I've got a y-intercept of 0, I've got a slope of 2, so the y and x version of this equation would look like this, and if I'm adding 0, I of course don't have to show that. Now if we look at what the options look like, we get y equals 2x for our familiar variables. Well, all of the options are in terms of the variables that they're kind of forcing us to utilize within this problem. So if you look at all of the options, you know, d is taking on the role of y, so we should be looking for a d on the left side of our answer choice, and then m is taking the place of x. So if I just swapped out this y for a d, and I just swapped out this x for an m, doing that quick swapping of variables should hopefully lead you to recognize that our answer is going to be option A. The one answer I would be worried about potentially getting if you made a common mistake would be option B. If you accidentally did run divided by rise, which is a mistake I know I see from time to time, then you get option B. But slope is definitely rise divided by run. Number 3 here, the paragraph leading up to the equation they present us with is kind of lengthy, kind of wordy, could possibly be thrown off by that. So if we check it out, they tell us that the formula that they give us is used by project managers to compute E, the estimated time to complete a job. O is the shortest possible completion time, P is the longest possible completion time, and M is the most likely completion time. And so this equation, we don't necessarily need to recognize where it comes from or anything. They present us with it, but what they ask us to do is they ask us to figure out which of the following options correctly gives P in terms of E, O, and M. So they basically want us to isolate the P in this equation. So if we're going to isolate the P within this equation, we're going to have to move everything on the right side of the equation onto the left side of the equation until the P is isolated. You're not going to have really any success in moving things freely from side to side unless the fraction is gone. So a logical first step here is to multiply both sides by 6, because what that does on the right side is it just gives us the numerator. Once the fraction is gone, and you have 6e on the left side of the equation, the only other step is really to move this variable and 4 times this variable onto the left. And to move those variables that are added on the right side of the equal sign, to move them to the left, I'm going to have to subtract letter O. I'm going to have to subtract 4m so that those cancel, leaving me with P isolated. My left side of the equation is going to be 6e minus the letter O minus 4m. And if you look, that is option A. I know my equation that I have written across on the other side of the screen here is kind of reversed from that, but the equation can read both ways. I can start here and say P is equal to everything that I have on that left-hand side. So we're definitely looking at option A for that one. This next one's probably the toughest of the bunch that we're looking at within this video. They give us a crazy looking diagram here. There's a bunch of triangles that we can identify within this diagram. The big piece of information that they do give us a few angles up here, but the big thing that we have to make sure we use the right way is the fact that side RT, which is right there, that is equal to side TU. So what that means, if you notice what I have up here in the upper right hand portion of my work, I've basically drawn triangle RTU in blue. I know that the 114 is the angle measure right here for angle T. The other thing that I have to recognize is that if these side lengths are equal to each other, the triangle that we're looking at right here is really an isosceles triangle. And in an isosceles triangle, the sides that have the same measure are going to come together to form a unique angle measure, but these other two angle measures are going to be equivalent to one another. And so I know that all 3 of these angles within this triangle have to add up to 180. I also know that R and U have the same measure, so rather than writing R plus U again, I'm going to just write it as 2 times R, right? I can replace the U with R since U is equal to R. And if I go ahead and try to solve this for the measure of angle R, what I end up with is 33 degrees. So angle R is going to be 33 degrees. Angle U, therefore, is also going to be 33 degrees. What can I do next? Well, if you look at this triangle, try to clean up my work here. If you look at this triangle, VSU, and I have that drawn here in red, I already knew that the upper left-hand angle measure of that triangle was 31 degrees. I've just determined through the work that we did with the initial triangle that the lower right-hand angle of that triangle is 33 degrees. What that's going to allow me to do is it's going to allow me to find this interior angle right here, angle V. And if I just use the fact that those 3 angles add up to 180, that'll allow me to determine that angle V is going to be equal to 118. Yeah, there's no calculator present here. Yeah, you have to be careful with some of the arithmetic that's being carried out, but just take a little bit of time, and it shouldn't be really that much of an issue for you. How can we finish this off? Well, if I shrink the picture here a little bit, across this bottom edge of the overall diagram, we have a straight line. On that straight line, we know that these two angles, angle 116 that we just found for angle V and angle X, which we actually have sitting as basically the exterior angle to this triangle right here, those are going to have to add together to 180. Those are supplementary angles. So if I use the fact that those need to add together to 180, that's going to lead me to my end result of 64 for angle X. And then the last question that we'll discuss within this video is a little bit easier than the one we just did, I think. They talk about a rectangular dance floor. So we've got a rectangle drawn here. They tell us that the width is W feet and the length is 6 feet longer than the width. So I just kind of generically labeled the triangle width and length, but then I also used the fact that they tell us that the length is, so the length equals the width plus 6 more feet. Which of the following expresses the perimeter in feet of the dance floor in terms of W? So I want the perimeter in terms of W. None of these answers down here involve L. So I know that perimeter in general is going to just be the distance around the triangle, not a triangle, that was the last question, distance around the rectangle. So the total distance around the rectangle is going to be 2 W's plus these 2 L's. But I want my answer to be written in terms of W. So I know, because they tell us this, that the length is equal to W plus 6. So if I just replace this L right here with W plus 6, I can then distribute this 2 into that set of parentheses. I can combine these like terms. 2W plus 2W is equal to 4W. And what I get for my perimeter is 4W plus 12.